So, hello everyone. It's another full stack deep learning study group, and we have more presentations for today. So we have, let's see where we're at. We have Avina's presentation on the model interoperability and overview, and also Sanyam's and Akash presentation on some open source tool, Jovian.io. So it's cool. Let me open my chat so I can also see.
I'll keep an eye out on the chat.
Okay, that's great. Thank you.
Yeah.
So let's maybe start with the. So we have about half an hour for each presentation. I think that should be fine. So let's maybe start with the full stack deep learning thing. So for today we had quite challenging agenda. A couple of lessons: 7, 8, 9, 10, 11. But actually 7, let me have a look. So 7, yeah. So lesson 7 is about the machine learning teams. And that was, sorry about it. That was about half an hour of video. Lesson 8 is not available, so that's easy. Lesson 9 was optional because that's a guest speaker and that's about 45 minutes of video. And then lesson 10, it's about troubleshooting. That's about an hour and a half. And then we said we're going to try to attempt the lesson 11, which is labs. But we said not all of them, but 6 and 7. So as we remember, labs were in the GitHub somewhere. So the labs were kind of split into 4 sessions, session 1, 2. So the third session is actually the lessons 7 and 8. That was the plan, by the way. So so we can start actually. So I can open slides actually. Yeah, okay. So I'm not going to go through all the slides as last time because there are too many of them, and I'm just going maybe to scroll, just ask questions or make some comments or anything related to the course, what was interesting, what was fun, what was not clear. We'll try to talk about this. Yeah, so he was talking about how many companies are struggling to hire AI experts. I believe that was the yeah, that was he was talking about. So it's a good thing for people looking for jobs, but at the same time, I think it's not easy to find a job without experience. That's another kind of comment that it's there around machine learning, finding jobs. Do you guys have some experience about finding jobs or looking for people, for experts in AI?
I have experience of getting rejected from Google.
Oh, yeah. I kind of confirm that from one point, people saying that's a lot of, there's a big demand for AI experts. On the other hand, yeah, I also heard that, and I kind of sent my couple of CVs myself. It's, yeah, it's interesting. Yeah, so there are different roles. So in machine learning, data science, AI, that's I think there are a couple of roles we could split that into. So like DevOps could be one role. So people who make the deployment of the machine learning models. The data engineers kind of might be a bit similar, but maybe more on the data. So they keep the look after the databases and stuff like that. Then the machine learning engineer, another similar kind of like, so we have machine learning researcher and machine learning engineer. So that's kind of very similar, but different again. Machine learning engineer is more about software side, software engineering side, and then machine learning researcher is more about the deep learning or machine learning algorithms, models, making them better. And then the data scientist is like everything else. It's like a very broad topic. Yeah, I think that's yeah. So again, the DevOps, data engineering, yeah, building data pipelines, machine learning engineer, train, deploy, research to train better models. Yeah, data scientist, everything else. So data scientist could be someone who works with Excel. It could be someone who works with TensorFlow. Yeah, it's just need to check the description of the job. I think that's what we're trying to say as well.
I think it's also worth mentioning that many startups especially use these terms very interchangeably. So someone might be hiring an ML engineer, but they might pitch it as a data scientist position. I've seen that for quite a bit of postings.
Yeah, yeah. And I've seen a lot of like, if you just type, let me try to open a new tab here. If you just type the data scientist machine learning, and just, yeah, those type of kind of, you see those a lot, those kind of like, what's data science, what's computer science, what's math. And every time you look at it, they are different. So there is no like common understanding. There's some of them like very interested in complex.
Yeah.
Some of them are more like basic, like the data scientist is someone who knows how to work with software, who knows math, and who's good at data communication, and that's a true data scientist. But then again, I've shown so many of those, and there's just no common understanding of what that is. It's yeah. So this one's different. This one's got data science on the right side, and IT skills, business skills. There's just no. Yeah, this one. Yeah, this one is like, again, data science is like a broad term, and then you have the AI, very broad field, and then machine learning, and then deep learning as a subset of machine learning. So yeah, I think this is fun, but we just need to check the job description, and some companies maybe it's got more specific descriptions. Some companies will have it like more broad. Maybe they don't know themselves what they want to do. So we just
someone is mentioned in the chat that they found the working of data kind was a great way of doing reasonable and popular projects than what to talk about. And also apparently it's difficult to join their team even as a volunteer.
Yeah. Yeah, data kind. I've heard about this. So,
I'm not sure. I think it's an NGO or maybe a research team.
Yeah, it's a non-profit, and they basically data scientists and developers work for free, and they have small team of project managers and that basically organize work. I think on this Slack I saw there was a call for volunteers to help judge Google.org challenge. I think that was a great experience. I think few people from here were working there. But after that, I started working with a local data kind in Washington, D.C. And then like once I started working on the project, like because they're kind of open, it's great that you can talk about the project, and the data kind has a good reputation. So it was like a good way of presenting skills.
So you can apply for like a internship?
Yeah, what I found is I registered online with them, but I never got a call for any project through registration online. But because I was on two Slacks, one for Google ML challenge,
Okay.
and another was for Washington DC chapter. Periodically they post different projects.
Okay.
And the skill match, You can.
I think you'll have to scroll to accept the terms.
Oh yeah. Nice one. Okay, I'm not going to do it now, but and the other one you mentioned, there are a couple of different places. There's a Slack, you said.
Yeah. So basically, they have a bunch of local chapters.
Data kind local chapters. Okay.
Yeah.
Okay. Yeah, the other one that was heard about this was the.
I think they have one in India as well. I'm not sure. Maybe in Bangalore.
Yeah, I think the one in Bangalore. Yeah.
Yeah, I think they had something. Let's have a look. Yeah, UK, Bangalore, India, Washington, DC, Singapore, San Francisco. Yeah.
So yeah, so my advice would be, I mean, just registering like didn't help, but like because I was able to start on one project, then getting on Slack, like then people start sharing opportunities.
Yeah.
That was
nice.
That was useful.
Can you do that remotely, or is it only like in person?
Yeah, so local chapters are usually they want local people, but a lot of times they post remote projects.
Okay, nice.
If I hear if anybody hears about another call for volunteers, like I'll post.
Yeah, that'd be great.
That'd be great.
Another one I've heard was the Fellowship AI, and
yeah.
I don't see this website working now.
I've also heard about Insight Fellows program. I think it's along similar lines.
So I have some experience with Insight Fellowship. I actually got accepted there to start last January, but I decided against joining. Just at work, they had a lot of interesting projects starting, and I was basically could do the same at work and get paid.
Yeah.
But Insight, it's basically they don't have any regular classes, but you do research like with them, and they sort of like lightly kind of supervise you, but they help you sell yourself. Okay. And then they work as a job placement. Basically, they get like some money from the company once you get hired. So it's completely free.
Interesting.
They have two programs like that. So one is Fast.ai, not Fast.ai. One is Insight Fellowship, and another is the Data Incubator. But Insight, I actually see a lot of people. A lot of people went through, especially coming from PhD. A lot of people went through that program. Like I see people who are working. Actually, a lot of people who Sam interviewed went through Insight.
Nice. Okay. Yeah, interesting. So the also Fellowship AI is, I guess, something similar. I think you have to apply for them and complete some sort of challenge project to get accepted. And then you kind of work with them for free. Again, it's not paid, but I guess you can learn for like this September, October, like 4 months. And after that, and they have a lot of different locations around the world. So because they don't accept remote, so you have to be in one of those positions. And then I think they help you to find a job or something like that. So, but it's again for 4 months, full time, do something for them and learn a lot. But yeah, okay, nice. The other side I found through I think it was through Slack, was kind of Delta helpers. So it's not to find a job or stuff, but there's a lot of like people who said on Twitter, I'm okay to help with questions and stuff. And the list is quite long, so I guess that's a good way to kind of ask people questions, how to get into data science, or how is the data scientists work day to day. So anyway, okay, interesting.
We're not seeing your screen if you're sharing it.
You don't see my screen? Yeah, I was hoping I can share my screen again. So I was showing that data helpers site, datahelpers.org. So there's like someone asked
We can
on
see
the,
it now.
can you see it? Yeah, good. Someone said on Twitter, hey, can you help with some questions in data science? And there's a lot of people said, yeah, I'm happy to help. So the list is quite long of people that said yes. And yeah, it's another resource of asking some people about data science. Yeah, so yeah, so then they're talking about the skills. So like the machine learning skills wise and software engineering. What do you need to know to kind of work in such a domain? So like the DevOps is mostly software engineering. Data engineering is software engineering with some ML experience. And of course the machine learning engineering. It's again machine learning plus some software engineering skills. The machine learning researcher is something that Jeremy Howard teaches us what to do. So that's mostly the Fast.ai courses, I guess. And the data scientists can be everything. And then they were talking about teams. And because they did some interviews about some companies about how to structure a team, but they didn't find any consensus, any right way to do it. So they're like every team is different, and they do it different ways. Yeah, I think that was quite interesting. And on a guest lecture, I forgot the person name, who was talking about the founder of the Weights and Biases. They found actually that the improvement of the accuracy of the model is mostly coming from the first like 2 weeks of working on the model. After that, you're not going to get a lot better. So I thought that was quite interesting. And that's similar from the other, Lucas. Lucas was talking about this as well. And he showed, there was no slides for that, but he showed the same, if I can find it. Yeah, I think that's exactly the same graphs. That's maybe they borrowed from him. Okay, so I'm not going to go through that. So what I found is that, I think that's the one in the middle, the accuracy of the best model goes up a lot in the first like 2 weeks, or even like 2 days. And after that, it doesn't help. Even like, I think that the one on the right is like number of participating teams, like on the Kaggle. It increases a lot, but the improvement is not getting better. So it's kind of like the sweet spot between accuracy and how much time you want to spend. I think they wanted to highlight that. I found this quite interesting. And of course, in Kaggle, you're going to win, even if you just like win 0.0001%. In normal projects, it's maybe not that important to get such an accuracy. Of course, the managing ML teams, like managing any teams, is kind of challenging. The ML teams, they're not that different, I guess. Yeah, the hiring, they were talking about more hiring, like LinkedIn, and we talked about some other also nice recruiting at conferences, this course. Like they talked about interviews a little bit. Some people still do the whiteboard coding. Some people ask you to do like pair programming. They would give you some quizzes. I think what's quite interesting, I think makes most sense these days, at least for me, is like the take-home ML projects. Although this can take a lot of work from you, but at least it's kind of more like a more real life project, because if you take that project home, you can Google, you can even find help from other people. This is how this works, right? Even if you work at a company, you're not going to do stuff on the whiteboard. You're going to use all the resources you can to solve that project. So for me, that kind of like makes sense. But it's going to take a lot of time from you, it's like a week or maybe even more sometimes. So that depends. They were talking how to prepare for interview. I think they were joking there's eggs on. Maybe there was, I don't know. Oh, maybe there was. Oh, forgot. Oh, there are some questions. I was watching those videos some time ago. I forgot about that. You want to answer those questions? Why does the residual block in the ResNet architecture help with the vanishing gradient problem? Well, I think because the any image of that? Oh yeah, you can find some ResNet. So the ResNet. Yeah, I think that's the ResNet stuff. So I think in ResNet we get this kind of blocks. Yeah, so compared to the kind of like a normal 34-layer plain layer network, we have those, they call the ResNet blocks, when they have the skip connections. So they go through the convolution layers, and then they get added the same signal as it goes into the layers, but without going through the layers. They kind of called the skip connection. So I believe those skip connections, they help you to avoid the vanishing gradient problem. That would be my answer to that question, at least. Suppose you have the following learning curve when the training on a single batch. Which of the following could be the cause? And this is, oh, this is the error. Okay. So the error is going up and down, but it's still roughly about 50%. It's not improving. Sometimes it's improving, sometimes it's getting worse. So what could be the problem then? Shuffled labels, learning rate too low, learning rate too high, numerical instability, too big a model. That's interesting. Do you have any idea? I'm not so sure.
Sagar has mentioned the learning rate is too high.
Yeah. Could be. Because if the learning rate is too low, you would be going like slowly, too slow to your minimum. But in this case, with iterations, we're not really going to a lower error rate. With a too high learning rate, that will be going maybe quicker to the minimum, but then it will go, I think, to some higher values. The shuffled labels. What do I mean by shuffled labels? I'm not so sure. With like a mixed labels? I don't know. Too big model? I don't think so. Maybe it's a learning rate thing. Question number 3. For each of the following prediction tasks, select the loss function that is best suited for. So they predict the sale price of a house listed for a sale. And then we have 5 answers. Okay, that's also a nice one. So we have the mean squared error, we have categorical cross entropy, binary cross entropy, CTC loss, and GAN loss. Okay, maybe I need to go through that lecture again. That was basically the lecture 7, lecture 8, and then lecture 9. I think it was interesting, but I'm going to treat this as the optional lecture. And then lecture 9, lecture 8 was about troubleshooting. Don't have a lot of time, but I like this picture. So you show like a lot of data in the model and just trust, yeah. And you just trust that you're going to get right output. And if it's not right, just throw more data or just mix with your data a little bit. So that's interesting. Yeah. So again, a lot of time is going to take for you to kind of debug your model. So there are a couple of I'm just going quickly because just ask questions or comments from that lecture because we don't have that much time to go in detail. Actually, I think this is the answers for those questions because this is the same graph, right? And they're talking here about the label side of work. So I guess get the results like this, that's going to be because of the shuffled labels. That must be the case. Okay, interesting. Yeah, they were talking how to find out if your model is performing poorly. And I like the idea. Yeah, I think this is quite interesting graph. So if you have your learning rate set right, to your minimum, but if your learning rate is too high, you're going to get quicker to your minimum, but it will not get as low as it should. But if it's too high learning rate, it will go up quickly. But if the learning rate is too low, it will get to low point, but it's going to be slow. But I think what was interesting for me was that, like they said, we should start. Yeah, and this slide was quite interesting. So the common data set construction issues. So we have not enough of data. So deep learning models, they need quite some data. So maybe if you can use transfer learning, maybe not that many data points, but if you start training from scratch, then you need quite some data. The class imbalances, so if one class got like 500 images, another class got just one couple of images, that's going to be an issue. The noisy labels, I guess this is when your labels not necessarily are true for the picture. So say if a picture of a car and then on a picture there's no car. And then when your training or your test set is coming from different distributions. So I think he was giving an example when you're training on like in an autonomous vehicle problem, when you're training pictures from like day pictures and then your tests are like from night. So that could be a complete different story. Yeah, and it's difficult to troubleshoot because you may have issues with your data, you may have issues with your code, you may have issues with the math behind it. So it's not so easy. So what they recommend, and that's actually quite true, just start simple and then gradually increase the complexity. And that's I was thinking about because what we've learned on Fast.ai, we've learned to use already quite complex models, right? Because by default Jeremy uses this like one cycle policy. There's a lot of like the dropouts and weight decays and all that stuff. So I was thinking about that, and maybe the next step, like to find out the simplest model and just to train a very simple model. But if Fast.ai works, then maybe Fast.ai is also a good start. Yeah, so that's kind of nice flowchart. Start simple, implement and debug, evaluate your model, tune hyperparameters, improve your data in the model, and if it is required, down. Start simple, so choose like simple architecture. I'm just going to go very quickly through that. Just ask questions or comments from this lecture because I think there's a lot of slides. There's like 140 slides and we don't have that much time. Yeah, so that's again kind of like because Jeremy is using ResNet out as a first model, and then actually they recommend something more simple like LeanIt. So there's different approaches to the same thing, but something to think about. Yeah, but they give you like some default options for optimizers, for example. So they Adam optimizer, so the same as in Fast.ai. It's also Adam optimizer. The learning rate 3 in 4. I think Jeremy uses like 3 in 3 or something like that. So it's close. Activation is ReLU, so that's the same what Jeremy is using. The he or her initialization is also the same. Regularization, they suggest to start with none. I think in the Fast.ai we get some, I'm not so sure. That's more about details. And also they recommend to start with a small training set, about 10,000 examples. And use a fixed number of objects, classes, and create as a simpler synthetic training set. I think it's a good advice. I was working recently on a Kaggle dataset, and that's like 260 training, 260,000 training images. And for some reason, the model was working very, very slow. So if you start with a huge number of images, you may have issues somewhere, and that's going to take you time to debug it and so on. So if you start with like reasonable number of images, make sure your model works, and then try to increase it. That maybe would make more sense. And also, this is kind of the same. Start with like small number of lines. I'm going to mute everyone. I want to so just unmute yourself. Yeah, just first of all, get your model to run. That's the first step. Apologies, I'm going so fast with that, but it's just too much of a stuff to cover in one half an hour. Yeah, so, and the next step they say it's overfit a single batch. So if you cannot overfit a single batch, then there's some issues with your model. So I think that's interesting thing. So they say just overfit your model first. And once you can do that, then you can try to optimize performance of your model. I think that's quite interesting. I'm going to skip some slides now to step 3. And it's also good if we have like known results. So like ImageNet, of course, we can compare ourselves to a lot of other guys who try to do the same thing. But in some cases, it's not possible, I guess. Like Kaggle gives you that possibility. You can compare your solution to other guys on a leaderboard, but in some cases, it's not possible. But at least if you can. Yeah, and then once you just keep iterating until your model performs up to expectations. So again, we don't have to make very precise up to 0.00001% model, just whatever makes sense for our project. And then they talk about what is a test error. It's a combination of more errors. It's just to be aware about that. Yeah, and again, he was talking about the training data could be from days scenes, and then test data could be from the night, and that's going to cause an issue for your model. What else? Right. So with your deep learning, you can have underfitting. So try to fix that. Try different, maybe different network, different model, more detailed model, like more parameters. Once you can overfit, then you need to deal with overfitting. So that's the next step. So once you start overfitting, then you need to address that by some sort of like dropouts and other regularization, other techniques that helps you with overfitting. I'm going to scroll quickly. Oh, the point C I've missed. So the address the distribution shift. So again, if we have different test set, different training set, different data sets, something to think about, and the rebalance data set if applicable. So yeah, if you have again night and day pictures, try to make them balanced. And that's another problem I had with that data set from Kaggle. I had like 1,000 classes, and some classes had like 500 pictures in it, and some classes only had like a couple of them. So I believe that also can cause an issue. So one technique for that would be to oversample. So you just basically take the same image a couple of times to make up for the missing numbers in that class. And then hyperparameter tuning. So like the hyperparameters, like how many layers in a network. So we can choose between ResNet 34, 50, 100, 150, I believe. The weight initialization, the kernel size could be different, stuff like that. You can choose different optimizers, different batch sizes, different learning rates. Yes, there's a lot of stuff to play with. And we can do this manually. So just try and error. Another one is like a grid search. So I believe there will be like certain tooling that would help you to search different hyperparameters. I don't know if they show any tools for that. Maybe in a different lectures, I think. Another one would be just random. I'm not so sure about this method, Bayesian hyperparameter optimization. So then at the end, he says that the debugging is hard. So we start iterative process, start simple, and then increase complexity. Start simple, implement and debug, evaluate, tune hyperparameters, and improve model and data. So that kind of like a workflow they propose, which kind of makes sense. And they give some of resources where we can learn more. So the machine learning, yearning. I think this is some sort of a book or something. I don't know what that is actually. Maybe you can check. So you can sign up for a draft free copy. Okay. I think it's a book, right? At least looks like a book.
It's a book by Andrew Ng, I think.
Okay. Yeah. Never heard about that one. So Andrew Karpathy's tweet. Okay, it's a long tweet. And maybe I need to read that one. Okay. And there's a blog post. Okay. So something for me to still read about. Some homework. Yeah, so that was lesson 10, which brings us to a lab session. But because I didn't do lab, I cannot talk much about the lab. So I still have lab to do as a homework. But if there's anyone else on the call that did the lab work and maybe wants to talk about this, we can listen to that. I can chat as well, but I don't see anyone volunteering to. So maybe we can shift labs to another session on the next week. That's what we could do. So do we have any more questions in the chat? Let's have a look.
Chat is clear right now. No questions so far.
Okay, that's great. So next week we're going to have our last session of that. No, is it? That's right. That's going to be last session. So we're going to finish the labs. So lecture 11, it's the labs 9 to 11, 6 to 9, and that's the LB. So that's end of the lab sessions. And then the lectures 12, 13. 12 is the testing and deployment, and 13 is the research directions. Unless lecture 14 is a guest lecture from Jeremy, and lecture 15 is a guest lecture from Richard. So those two again are optional. So if we don't count the optional, we have 2 video lectures and the labs 8 and 9 for next week. Okay, excellent. So we also in the agenda had the Avinash's presentation. Do we have Avinash in the call?
So there's a question from Sagar. He mentions, he says if he wants to ask if anyone has had the chance to try the tools mentioned in the data management or infrastructure and tooling lecture.
Yeah, so I didn't, and indeed they showed a lot of tools in the presentation. They showed a lot of tools. I'm just I'll try to show that page again. This kind of is from Google, from some paper from Google. They say this is your ML code, and it's so small compared to the whole ecosystem of deep learning. So that just shows the how big that is. And then they show this picture, which shows like all sorts of different tools for different problems. I've logged into the weights and biases, but because I could not run that lab because I couldn't install the Torch libraries for some reason. I couldn't run it, but there's a lot of tools to try, but also need a lot of time.
Actually, we'll also be doing a presentation of a tool today also.
Yeah.
A tool that I mentioned.
Excellent, excellent. Okay, so we can move on to next presentation. Unless there are more questions. Yeah, the question, how to practice labs? I don't know actually to answer the best answer to that. So all the code is here in a GitHub, and in a lecture they use the weights and biases, and they have the code to run the Jupyter Notebooks from there. But because we don't have that code anymore, it doesn't work anymore, we have to find a way to do it. And so far I did not find a way to do it. I know some people did, it's like Michael, he managed to run the code, but and he used Conda instead of the pipenv as they recommend here. Because it's TensorFlow, I had some issues installing some TensorFlow libraries.
I think PyTorch requires CUDA 10 and TensorFlow requires CUDA 9. I don't know if that's changed now. Maybe that was issue.
Yeah, because they give you like installation setup, how to set up thing, but so I followed that, but it didn't work, so I didn't have time to debug it. But if someone know how to do it and wants to show it to us, other people how to do it, that would be great.
I haven't tried it yet.
Yeah.
Also, heads up to everyone, if you try installing Swift for TensorFlow, I ended up breaking everything to an extent that even Zoom is crashing. So,
yeah,
a word of caution.
Exactly. So yeah, so that's the kind of, because this was created as a bootcamp thing, it wasn't created as a MOOC, so they never really, if I go back.
Sagar has mentioned it's a problem with TensorFlow's newest version.
Yeah.
I think his comment is related to the lab.
Yeah. because that was created as a bootcamp one of them. It's not a MOOC officially, so I guess no one is really maintaining that repo or making sure it works still. So it's nice we can use it and nice we can see all the videos, but yeah, maybe the code needs some, updating or, maintaining.
Yeah.
So that's the thing. But we'll try for next week. If we cannot make it work, it's a shame, but yeah. So Sanyan, do you want to take over the presentation and present the
Sure.
the JVM tool?
Definitely. I just requested Avinash. He's agreed that I can go first. My Zoom is crashing constantly because of the Swift thingy. So Akash will do the presentation and I'll monitor the chat side by side.
Yeah. Hi everyone. This is Akash here. I hope you can see me. Yeah, there. I can see my video. Great. Yeah, great. It's great to be. I was actually listening in for the past half an hour. Great discussion. I wonder why I haven't been participating, been part of this earlier. But yeah, it's so maybe I'll. Can I share my screen?
Yeah, sure.
Yeah.
I'll stop sharing.
Meanwhile, to those unaware, there's been this huge meetup in India that was being run by Akash. So all of the Bangalore meetups around Fast.ai and even data science would have been mostly from Akash to those who might have attended.
Excellent. I think this is like the PyTorch from zero to wherever.
Yeah, he's the author of it.
Excellent. Nice.
All right. Great. Thanks, Ayam. So, okay, I'm going to share my screen. I hope this works. Great. Cool. Can you see my screen?
Yep.
Yes.
Okay, awesome. So, yeah, quick introduction, guys. My name is Akash. I'm joining from Bangalore. The first time I'm joining the TWiML AI study group call. So the just quick background about myself. I was a software engineer for a few years and then switched over to machine learning after doing the Fast.ai course online. And that just completely changed my perspective on how we were looking at data science and machine learning. Like in college, it was so mathematical and so dry, but Fast.ai was so hands-on. So that's how I got involved and actually switched over my career completely, started doing ML consulting work and freelancing, while also and as part of this, I also, like, along with a friend of mine, we realized that although there are a lot of people who are interested in data science in India, in Bangalore, but there's no good community, especially having a lot of technical talks. There's too much networking and that kind of stuff. So we started the Data Science Network about 8 months ago, and it has been a wonderful journey. Like, so far, we've had about 5,000 members in our meetup groups, and we have meetups every other week. So yeah, just really excited to be part of the data science community and learning new things every day. So what I'm here to present today is the tool that I've been working on with a few friends, and like Sayam has also been involved recently. This is a tool called Jovian. This is something that was born out of our own problem that we really love Jupyter Notebooks, the interactive nature, the way we can plot graphs and go back and forth and fix things. I felt like that really opened up things for me in terms of trying a lot of experiments out. But it also led to a lot of problems, especially coming from a software engineering background. I was used to having like Git kind of a workflow where you sort of branch out, make some change, and come back. But what really happens, what we've seen happens in a lot of machine learning projects is something like this. Right? So the question we asked ourselves is, how are we tracking our machine learning experiments, all the different ideas that we're trying? Notebooks are great to try things out, but then because they are so rich, they have so many graphs and things like that, they can be large in size. What we tend to do is we tend to keep creating copies and copies of data. So this is just like one particular project that I was working on, where we had over a course of 3 months, we had like 60 different notebooks. And then we would try to put everything into just the file name, so that, and this would be sitting there lying on a cloud machine, and there's no sense putting this into Git, because this is like 200 MB of Jupyter Notebooks. So that became, that we found that very tricky. We also tried using log files, but then log files are sort of even trickier, where you have like a code in a notebook which you have updated, but then your log file looks something like this, where you have to sort of go into it and try and parse things out. It's a big mess, right? We tried spreadsheets as well, where we would sort of keep track of things in a spreadsheet, like on what date, which experiments, which network we tried, what hyperparameters we used, and what kind of results we got. But that also sort of made things really messy, because now you have your notebook somewhere, and then you have your data somewhere, and then you have maybe your checkpoints and models somewhere, and nobody has really kept track of the libraries. So TensorFlow is updated, PyTorch is updated, and it gets all very messy. So we started creating a tool for ourselves, and that's what I want to show you. The goal was to start with Jupyter Notebooks and make them more shareable, make them like collaborative, so that people can work together on a single notebook, try different ideas, and manage the entire workflow around them. Right. So I will quickly jump into an example. I guess that's the best way to do it. So this is this Jupyter notebook running on my local host. It's an example of classifying handwritten digits from the MNIST dataset by just training a CNN using Keras. It's pretty straightforward. You prepare some data, download the data, take a look at the data, and then do some pre-processing, one hot encoding. I have some like a 2 categorical, which does like 1 hot encoding here. Then, as you start out, as we just saw in the lecture, that you start with a very simple model. So I have a very simple model, a single conv layer, 32 filters, and then I just flatten that and pass it through a fully connected layer, right? Then I compile it, I train it, I look at the accuracy. Okay, that looks pretty good. Maybe it also helps to look at how the model was training, so I can plot how the accuracy is changing. So I guess the dots are the training loss, and the validation loss is the line. So the pretty standard model, right? And then finally you evaluate it on the test set and then get the accuracy and loss. Now, suppose you want to share this with somebody so that they can try it out as well, right? Maybe you're doing this on your local machine or your Google machine, on your GCP cloud machine. You want to send it across to somebody, just get quick thoughts, get maybe some inputs, maybe they're helping you learn. This is where our tool comes in, Jovian. So you can just simply install pip install Jovian. And yeah, I think I already have it. Then you import the library, and then you just say jovian.commit. Okay, and when you say that, it asks you to provide an API key. An API key is something that you can find by simply logging into the website. It's okay. I'm already logged in, I guess. So I'm just gonna copy. It's a one-click login with GitHub. So I just it just gives me an API key which I can enter here. Now, once I do this, what we do is we take a snapshot of the Jupyter notebook. We take a snapshot of the entire backing environment. So here I'm using Anaconda. We capture the Anaconda environment behind the scenes. And I'd like to ask you, do you know how to export the Anaconda environment? Because there's a really complex command that you have to try, especially to make sure that the environment is reproducible across, between like Mac OS and Linux and Windows. But anyway, we do a bunch of these things behind the scenes, and then we we upload it to the cloud, and you get a quick like a URL where you can see the notebook. So you don't need to have Jupyter running. You can, the notebook is there. Apart from that, we also have all the file. We also have the environment that has been captured. So these are all the libraries that I'm using here, right? And then you can simply take this link, as I'm taking right now, and you can simply take this link and send it to someone. And there, then now you can click the link and now you can try it out. Now, if you want to try this out on your own machine, all you need to do is you can click the clone button. Now go back to your terminal. Let me open a new one here. Let me just rename this to something nice. Yeah, there you go. Okay, so I'm just gonna run the clone command. Again, to run this clone command, I need to have the Jovian library installed. So I'll do like pip install Jovian, which in my case I already do. but just to show you. And this installs a CLI command called Jovian. So that's where you can paste the command that gets copied when you click the clone button. And that downloads all the files and it gives you a bunch of instructions for what you need to do next, right? So I'm just going to enter this directory, run this Jovian install command. So what this does, the Jovian install, depending on, like, as you can see here, I have an environment.yaml file, environment.macOS file. So it looks into if there's a environment specific, if the OS specific file, it uses that. Otherwise, it uses environment.yaml. The reason we need to do this is because Conda environments and Conda packages have different versions across different platforms. So sometimes things don't work, sometimes things fail, and then it just errors out. So what we do is we try to install. If there's an error, we comment out those lines from your environment, try to make a best set and try this 3-4 times till the entire environment is installed, right? And this has been an open issue on Anaconda for over a year, where people are saying, I just can't reuse my environment file. But we've tried to solve that with just doing a few hacks and trying the next best thing. But yeah, so what this does, you could do some work on your local machine and then maybe push it to Jovian and then open it up on your cloud machine, pull from there, clone from there, and start running, right? So now at this point, if I run the conda activate command, that activates my new environment, which was just created, and I can go Jupyter Notebook and start playing around with that notebook, right? So simple push and simple commit and clone flow that we do. Now, the next thing that we've also done on top of this is maybe you're just looking for some feedback or some inputs. So what we've done is we've built out a commenting interface on top of Jupyter. So for instance, if you have a question very specifically about, let's say, about the model, somebody has a question saying, why are you using kernel size 32? So they can just comment it on that particular cell, and then I will get an email notification where I can click through and reply to them, and then they will get an email notification, right? So this allows for very quick feedback and discussion on Jupyter Notebooks. When you are, one person can actually do the coding and the others can all come in and give their thoughts on it. This was something that we found missing, so we just decided to add that as well. So next, the way we use it is we run some workshops here. So often we put all the Jupyter Notebooks, environments, everything on Jovian, and then let people clone it, try out something on their own, and then push the new versions and then get feedback from us, right? So that it helps us do that very easily. Okay, so coming back to this now, one thing is that, okay, it's great that I have the Jupyter Notebook. It's great that I have the environment. I can reproduce it. But what ends up happening is, even if you just you make some changes, you create a new version, you ultimately start ending up with like a half a dozen or so Jupyter Notebooks, right? And what you really want is, and what you really want is you want to be able to track specific things about notebooks. Like for instance, in this notebook or in this experiment, what are the hyperparameters I tried and what were the success metrics I got, right? So that's where we have created a very simple API as well. Is there a question? Okay. Yeah, that's where we have created a very simple API as well. All you need to do is just import Jovian, and then we have a couple of APIs. We have log hyperparams. Okay, so this is to log hyperparameters. So for instance, here I'm just going to add a small note about the architecture, that this is simply a conv 32 plus dense, right? Maybe I'll also add a note about the batch size. The batch size I'm using is 128. I'm using 3 epochs. And what else? Yeah, what else is interesting here? I think I'm using the RMS prop optimizer. Right. So this is currently a bit manual, but what we're trying to do is, when you do a model.fit, we're trying to create a callback so that all of this information can be picked up automatically. But I just wanted to show you the basic API, and then I do that. So that logs the hyperparameters. Then once the model is trained, I might also want to actually keep track of the metrics. So that's where I can do jovian.log metrics. And here I'm just going to put in these things. So
I wanted to mention that even for casual competitions, like this is how most people usually track. Like they have multiple notebooks and then they create spreadsheets. So this is essentially looking at replacing it with just one single interface.
yeah. And right now I'm actually having to type a lot, but the idea is this will be just like a single callback that you introduce into your history. At least for the popular frameworks. So now I've captured some metrics, I've captured some hyperparameters, and we'll take a look at what they look like. But apart from that, the other thing is also that, I might, this code, this might be some, common code that I use across all my notebooks. So I might actually put this in like a utils file, right? So maybe I'll do like, create a utils file, and put this here, call this plot history. Okay, very simple. And I'm just going to import from utils, import plot history, and then we'll just plot the history. It does the same thing, right? So now I also have a dependency on a certain file. And another thing is, like, I've trained this model. Maybe this is a simple example, but then in certain cases, your model can actually have been trained for a long time, and you might want to just keep the save the weights. So that's where you probably want to do something like you want to save the model as well. So I'm just going to save the model.save mscnn .h5. Okay. And yeah, so now I have like a dependency on a file. I've logged some hyperparameters, some metrics. This time when I commit, what I'm going to do is I'm also going to include the files that I depend on. So this is utils.py and the artifacts that I've generated. So this is like mnist cnn.h5, right? So now I commit once again. And what it does is it updates that notebook. So it creates a new version essentially. Once again, it captures the environment to make sure if you've added any new libraries, they get captured. Any additional files and any artifacts are also captured, and also the metrics and hyperparameters. Everything is then taken, and then now you have start to have a more complete picture of your experiment, right? So you have the notebook, you have environment, you have the utils file right here, you have the artifact. Now we are trying to differentiate between sources and artifacts because as you might have faced, if you train a ResNet 152 and then save a checkpoint, that's going to be like a 120 MB file. If you check that into Git and then you train 2 or 3 more of these, suddenly you have a Git repository that's 1 GB. So every time you push and somebody tries to pull it, they're downloading 1 GB worth of stuff because the weights change every single time, right? So that's why we differentiate between artifacts and sources, and artifact, and we provide an option to actually clone without actually downloading the artifact, because if you just want to reproduce it, you probably don't need it. On the other hand, if you just need the artifact, you can download it right here as well. So that's the files, the dependency and the artifact. But also this is where it starts to get interesting, where now you start to get, as you log some hyperparameters and some metrics, you start to get a timeline of what was actually happening in this project. So I have here, it's a conf 32 with a dense with 3 POCs, RMS prop, and I got to an accuracy of 97%. That's pretty good, but maybe I can do better. And as you start to sort of keep doing this for multiple times, start to record multiple versions, what you can do is, so here I have another, the same example that I've tried a few versions. So you can check the versions. Okay, not here. Yeah, so same example I've tried. I've recorded a few versions, and all the versions are visible here in the version dropdown. And I can actually go click on compare versions, right? So now whichever version has a record, all those records show up here. So I can see when it was created, who created it. So I'll come back to this, the nodes that I've added here, and the hyperparameters and the metrics. So it starts to give you a good overview. One thing that we've added, and we're adding more things, is you can select which columns you're interested in. Maybe epochs is not that important. Maybe you don't need hyperparameters at all. So you can just look at the metrics. Another thing that we're doing is, if you have some runs which you're not interested in, you can actually just select them and remove them. You can reorder the columns. You can add in notes here. Come and change an entry because maybe it was recorded incorrectly, right? So we're trying to make this very powerful, pretty much almost as powerful as a spreadsheet, but then more targeted for the data science use case. Okay, and then finally, the last thing that I want to show you is collaboration. So now this is just me working and maybe me sharing with somebody, but you can see here that there are other authors here as well. That's where we have an option. So a bunch of things. One is visibility, that if you want to, so currently this is a public notebook. Anybody can go on my profile and find it. I can make it secret so that only people with the link can access it. We're also working on private notebooks so that you have to be logged in and added as a collaborator. I can archive this notebook once it starts to get filled up on my profile. And then finally, I can add collaborators. So I can just enter their username yeah, and that will add them as a collaborator. There you go, right? So now what happens is every time they clone and they try to commit, this is going to add to this particular project itself, right? So slowly, starting from a notebook, we're just trying to build a complete story of a machine learning project, and trying to make it as seamless as possible, so that as a ML student or engineer or data scientist, you have to do minimum work. We have been trying this for about 4 or 5 months now, using it in workshops. It has been pretty helpful for us. A few community a few inputs for the community were, hey, this is great, but what if I want to be able to run this immediately as well. So that's where we have created integrations with Binder and Kaggle. So if I click run on Binder, what this does is this immediately goes to mybinder.org. I don't know if you're familiar. MyBinder is like a free hosted Jupyter notebook, which can create run a Jupyter notebook instantly from any repository, Git repository. So that's what we've added. It's going to take a time. Oh, where? Okay. So it looks like, and what it does is it actually caches. So first time you click, it's going to install all these things, but next time it's just going to keep a Docker image around so that this can start immediately. Another thing is, if you want to use a GPU, you can click run on Kaggle, and then this will run immediately on your Kaggle account, right? And you just need to connect your Kaggle account. There you go. Yeah. So yeah, so that's pretty much it from my end. I don't know why this is not working. Okay, I'll look into this. We're also adding Colab and a bunch of other platforms soon. But yeah, that's it. So that's pretty much on our end. Just wanted to show you what we are building, and if it is useful. So we are still, I would say, we are still in beta. We're still building. We have a lot of things working, but there's still a long way we want to go. So would love, if you could try it out, give us feedback, tell us what you would want in this, because we are very open to just trying to just building what will serve the users best, right? Yeah, and we have been personally using it more as like in Kaggle competitions, as like a internal leaderboard to keep track of who's doing what, and we can quickly click through, see their approach, see their loss, see their notes, and things like that, right? So building it as we use it. Yeah, so that's pretty much it. If you have any questions, I'm happy to answer.
Thank you. Looks very good, very nice,
Yep.
Very like complete picture. So I didn't know about this tool, so now I know a lot. I've been trying to use also Kaggle's got something kind of not similar, but at least they have this idea of committing your kernels.
Yes.
So on Kaggle you can commit, and then it saves your data. It
Yes.
saves your notebook, and then it saves your output files.
Yes.
But it doesn't save all the nice information as you have like architecture epochs. It doesn't have that
Right.
much. It's not that rich. Yeah.
Yep.
Nice.
One thing also is that Kaggle, it has to be you sort of have to commit it on Kaggle, so you can't really run it on your local machine.
That's right.
We wanted to have it flexible and have it open. Yeah. Another quick note is that this is most of this is open source. So the Jovian Python library is completely open source. We're trying to open source the backend as well, but it's just we have to pull out all the specific backend specific things before we can make it generalized enough. So yeah, I'll post this link here as well in case you want to try it out. If you're facing issues, you can always reach out to us here or send a pull request.
The other thing, whatever isn't open source is free and will stay that way.
Yeah.
Right. Thank you.
How I envision it is like, if especially for Kaggle, like if you're running something locally and then you also want to run it on a kernel and you like want to get away from the flakiness of the kernel, you can run it locally. And say if you're participating in a kernels only competition, you get to run it on a kernel. Or if you want to check it out on an AWS instance, like if you want to run a beefy XGBoost model, you could rent a 32-core machine, just run it there, get the trained weights, then have the inference run on Kaggle kernel inference only competition or even locally. So that's also something you can do with this very easily.
Yeah, sounds right.
Okay. All right, and you can reach out to me in case you have any questions. I think Sanyam will share the contact details possibly.
Yeah.
Right. Okay. So I'm gonna stop. Yeah.
You can join our Slack as well, so people can ask there. Yeah.
Yeah, that's great. I would love to. Yeah, I'll be there on the Slack then.
Yeah, then we can ask questions directly, I guess.
Great. Thanks.
I'll share the link in the Slack as well. Like if anyone has any feedback, Akash is very open to community feedback also. So please ping me or him once he joins for any feedback or suggestions.
Excellent, thank you. So thank you for the presentation. We have one more presentation for today. It's Avinash is going to present.
Yeah. Hi, Michael.
Hi.
Am I properly audible? Yeah. Hi.
Yes.
So do you want me? Do you want me to take the presentation today or?
Yes, it's 7:20. Maybe you can at least tell us what you want to talk about, and if that's not enough time for you, then maybe we can reschedule. But what do you think? Can I hear you, Avinash? Hello, Avinash, still there?
Can you hear me now?
Yeah, we can hear you now.
Yeah. So the presentation that I wanted to do was on model interpretability and visualization.
Mm-hmm.
In that, I will be walking through a Kaggle kernel.
Okay.
So it's on food classification, like hot dog version 2, where it doesn't just say whether it's hot dog or not. It can also detect the other classes of food. So using that, I'll be explaining how the inner layer activations look and also a bit about activation maps.
Mm-hmm.
So this is what the talk is going to be, but I feel it is going to take at least 20 to 25 minutes for the entire thing.
Got it. And you're okay to talk next week, or?
Yeah, I'm fine with that.
Okay.
If you could just share the link with us, we'll check it out for the week. Or the
Sure. Yeah.
Avinash, really sorry if I took up too much time.
Sorry?
I'm saying I'm really sorry if I took up some of your time.
No, not at all, Akash. It was very good presentation.
Okay, thanks.
Yeah. So I'll share the link, the Kaggle kernel link, and we can discuss that in the next week's session.
Fine.
Sounds good.
Yeah.
Okay,
great. So we'll move that for next week. Do you have anything else to share for today? Any news?
I have some open slots for the chai time data science conversation that I've shared for this upcoming week. So if anyone wants to talk about anything, please feel free to schedule a talk with me.
What is what's the most things people like to talk about in these discussions? Can you? I don't want to hear like names and things. Just might be some statistics. What's the most interesting talks? Most asked things about?
It's all sorts of things, but like I guess Kaggle and Fast.ai,
Mm-hmm.
then machine learning jobs.
Okay, nice, nice. That's very nice of you, Sanyam. Thank
Just
you.
trying to help as many
Yeah,
people.
it's nice. It's nice. So when I found this page on data helpers, maybe something you would be interested to add your name to it. I was thinking.
I just learned about it today. I have the tab open. I'll check it out after this.
Yeah,
Thanks.
yeah, that's excellent. That's excellent. Okay. So if that's everything for today, I guess we'll just close for today, and we'll meet next week, the same time, the same day, for our last session of. I'm going to show it again, if I can still.
Also,
Okay.
we're still open for suggestions. Hopefully, if Fast.ai is released by then to the public, we could start a Fast.ai session as well. I'll be happy to volunteer to take those meetups up.
Yeah, indeed. Good you mentioned that. I forgot about this. So indeed, it's so next week we're going to have our. I hope you can see my screen now.
Yeah.
Yeah. So next week we're going to have the last fast full stack deep learning study group thing, and then it's a blank page. So I've collected from all the from Slack, from what people were saying, that what potentially we could do next, like secure and private AI. There were some people interested doing ML course from Open Data Science, which starts September 2nd, I think, for the last session of that course in the current format. There was like advanced NLP with Spacey. All of those are free, by the way, so it's a good, like, we can do all of them. Fast.ai released, kind of silently released, quietly released NLP, because the videos are not released yet, so it's only notebooks. The statistical learning is more like machine learning from Stanford, free. Introduction with PyTorch, free. There were some Stanford courses on NLP. Recommended the deep unsupervised learning, but we cannot do all of them at once. Well, we could if we create like separate groups led by different people and meeting at some times, maybe even overlapping with some others. So that's another option. We could do more courses, but then there will be like smaller groups doing the courses. Or we could try to keep it as one group and then just select a course. Of course, something that a lot of us, this is how the group started, was the Fast.ai deep learning course, part 1, was by June last year, I think. So the part 2, it's not released to public yet, and I didn't hear when they're going to do it.
They
So,
mentioned June, but I'm not sure if that still holds.
yeah, exactly. I think they're now busy with they're now busy with updating the Fast.ai library to V version 2. So I'm not sure what's the priority for them now, because they also promised a couple of lectures, live stream lectures to the part 2 course, which also it's not sure when they're going to be available. Yeah. So we can continue that discussion on a Slack, but yeah, it's just up to us to decide what to do next, I guess.
I want to suggest that I gave these courses a look, and in my opinion, like most of these things are covered in Fast.ai, except for security in AI. So, and personally, I'd also like to just go through the. Anyways, I will be going through the materials again from part 2. So it'll be really cool to have other people also join in the study group. But again, like I'll wait for the common opinion there.
Yeah. Yes, it's a fair point, because the Fast.ai part 2 was closed, was only open to some people.
Yeah.
So when they open this to the public, to general public, I think it makes sense to kind of do it again. I tentatively put like one lecture per 2 weeks, because those lectures are quite heavy, I guess.
They're very dense.
Yeah. So maybe that's an idea, to do like one lecture. So we can meet every week, but then we can split a lecture in 2 halves and then talk about one lecture for 2 weeks, maybe. Okay. Excellent. So let's continue the discussion on Slack. And next week we still talk Fast.ai, sorry, full stack deep learning. And I'm going to move the Avinash's presentation for next week. So at least we have also agenda. Also, the Daniel and Abhinav, they also wanted to talk about deployment of deep learning models, but then they put it on hold. So maybe they also talk about this in the future soon. Okay, excellent. So thank you for joining today. Talk to you next week.
Thank you for hosting, Michael.
Thank you.